Okay, we are going on the record. So it is an attempt to molecular dynamics on VASP. So right now we are logged into the HPC cluster. The directory is my name, and selecting the model of periodic polymer. So we are in the directory with periodic model. One of the important skills that we have learned in the last homework and last is that one needs to open new directories and pull forward the concar into postcar. So funnel the output geometry from one run as an input geometry for another run. So another important thing that we need to prepare to assign initial velocity to set up a thermostat. So the goal is to run molecular dynamics to model this material at ambient room temperature. So I'm opening C4H4 periodic, and I will call it heat. Let's say, well, 300 Kelvin is boring. I will start immediately with, let's say, 1000 Kelvin. The name of directory should reflect the content. I'm copying concar from this directory into the Oscar, into new directory. Then I am copying everything except, so I'm cp car and key points. Now I'm going to the new directory. Going to the new directory, flashing the screen. Okay, so we do have 3 files, and we do not have incar. I'm copying the incar from the template, binary incar, select one that has heat, dash, heat, here as an incar. Control L. Let me show it once again. So here is the command. Copy from binary incar subdirectory incar dash heat into here and the name incar. Done. More incar. So right now we do not care about service information, but we need to focus on the temperature that is going to be established with this input file, with this request to job. So I'm typing vi incar and going to the beginning temperature of the thermostat. I do not want 300, I want 1000. So we are putting our model onto the hot plate, heat it to 1000 Kelvin. Let's go see what else. And there we are going to let it stay there for 300 steps, which is too long. 300 is a good number if you do it for research, but now for educational purposes we put some small number like 50 steps, and time step will be 0.1 femtoseconds. Escape, column, right, quit. Once again, more in car. So it contains requested temperature, and it contains time, ramping time, that the model will stay on the hot plate. Okay? Now I am just typing run VASP. And if it will not work, I will, there is a backup. So more job. Let me use that. So the job is running. Okay. So right now the instructional part is put on hold, and I'm just as a user watching the job is running well. By the way, one can watch command allows to see something repeatedly again and again. For example, I can do watch of the qstat or watch of the list of files. So you see the job is still running. It has the KR, and we do see that the output files are being developed quick enough. They grow, car is growing, Aussie car is growing, and we can, if we are curious, instead of watching the you can watch the progress of the Aussie car file. So, font. See, now it is step 47, 48, so we quickly reach the request. We are reaching 50 steps in a reasonable time. And here, these two steps are electronic conversions, and these steps, step number 47, 48, those are ionic conversions. So the two flowchart diagrams inside each other. You see, at the beginning of this if we check qstat, so job is complete. Tail out car. So out car has the spent time 86 seconds, which means that it is a normal termination of job. So the main outcome, main result of this run is the file count car. I'm looking into it, and let's analyze how does it look like. So first, it has type of elements, it has the size of the box, number of elements of each type, already know. List of coordinates. So first 4 coordinates will be, last 4 are for regions. But then there is an additional segment of data. What are those data? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. And they do not have this T label. There are 3 table of 8 records, each of which has 3 numbers. So those are values of momenta or values of velocity for each of ions in the same sequence, in the same order. So right now, due to this thermostat, due to this heating procedure, we have assigned velocities to each ion in a reasonable way that it approximately corresponds to 1000 Kelvin. Okay? Done with heating. Now, the new job is molecular dynamics. So we need to have mu direct for any new job. Otherwise, it will be a mess. So I am telling it make directory C4H4 periodic, and now I will call it MD underscore 1000 Kelvin. Okay. And now I am doing the same procedure as we were doing before. So it is very important. If I do not use the cont car, if I do not funnel it into new directory, then nothing will work. We need specific cont car that has been created in this part, in this heating thermal. Here, we need it to be transferred to new directory. So copy cont car into pos car in the new directory. Click, ready. Now we are taking the potentials, pot car, and K points into there. Good. Now we are ready to go to this directory ourselves. So in this new directory, I'm going to wipe off the screen. This new directory, ls. We do have 3 files. We are missing in-car, and we are copying in-car, which is appropriate for molecular dynamics, from our template. In-car is, there should be md into this directory, period, slash, under the name in-car. Okay, I'm wiping off the screen. More in-car. How does it look like? Well, there are temperature. The temperature here is different. Is electronic temperature that affects the thermal distribution. So the only thing that is important here is at the end, NSW. So we model by putting it on thermostat, and now we have a model at ambient temperature. For us it is 1000 Kelvin, and we want to run it for as many steps as we request here, 1000 steps, which is a little, it's very reasonable for research, but for our educational purposes we can do 50 or let's say 100. So I'm going to edit in-car just as a proof of concept. So in-car, I'm making consistency between our ionic temperature and electronic temperature. Although these parameters are secondary, they are more important for electronic structure, not for the interfact dynamics too much. And here, instead of 1000, I leave only 100 with a time step of 1 femtosecond. Escape, right quit. ls minus t. We do have 4 input files. And I'm going to run this job here, right now, immediately. So, what I'm typing run VASP, bigger, my GOB. More, and now I'm qstat if this job has been run. Okay, it is running right now. So I can repeat the same command in the watch mode, which means it will be dynamically run again and again. You see in the upper right there is time that is changing, and this time in European mode. 16 hours means 4 p.m. or after 12. And you see the job is still running. We can add here -ot add to see that files are being developed. So there is an Aussie car, out car, good. Or we can follow the tail Aussie car. So Aussie car shows the progress of iteration cycles. Aussie car shows how the electronic convergence is going and how ionic convergence is going. So if we are modeling small systems, then fluctuations of the temperature in comparison to what we have prepared to the thermostat are huge. So here we have just 8 atoms, so it may fluctuate to any value. If you do more than 100 atoms, then the temperature, see here it tracks the value of temperature at each time step. We have requested 100 steps, and now we are already on 49th. And temperature is much bigger, or sometimes because of the fluctuations, because of the small number of atoms where statistics doesn't work. But we are doing proof of concept. In big systems, the temperature of the system will be very, very close to what you request. 3000. Well, if temperature goes too high, it may be a signature of the decomposition. It may be a signature of reaction with generation of heat. So let's practice our patience and wait until number will come to 100, and then we will analyze the result. Few more minutes. 79, 80. 84. So while watching it, you can see that the second column shows total energy minus 165 electron volts. The second shows between values of total energy at each iteration, and the last one shows the change of the in force column. So when the change of the change approaches value, then we go to next electronic iteration. So you see this R, this qstat command stops showing us progress on this job because it has been completed. We reached the value 100, and we do have a lot of new files. So the most important file is outcar, and there is a way to convert. Outcar has a lot of information, but we may extract only critically important, pleasant, simple information. So there is a x dot to xyz applies immediately to the outcar. After it runs, we get the file named movie xyz, and if you do more movie xyz, we see that it has snapshots of molecular dynamics of the nuclear configuration at each time step. 4 carbons, 4 hydrogens. And if you go, it will be 4 carbons, 4 hydrogens. It is expected to be different.